Okay, so today's lesson is topic 1, types of structures. So this is our new unit called structures and forces. So what is a structure? So a structure is defined as an object with a definite shape and size. It serves a purpose or function. A function is another word for its purpose. Okay, so it has a purpose. There's a purpose for that structure or object. The parts of a structure, they usually have a specific arrangement that remains the same, and every part of the structure has to be able to resist forces. So forces, these are stresses such as pushes or pulls, and a load, this is the weight that is carried or supported by a structure. So for example, a brick wall. A brick wall, it has to be able to withstand the force of wind. The bricks on the bottom of the wall have to be able to support the weight of the bricks above. And if a person, for example, climbs on top of the wall, the bricks have to be able to support that load as well. Okay, so we're going to talk about how to classify structures. So there are natural structures. These are not made by people, okay? They are occurring in nature. So for example, birds' feathers are structures. It has a definite shape. It's made of many parts that are held together in a complex pattern. Purposes include insulating the bird in cold weather, protection from rain because they're usually waterproof, as well as flight. So here are some structures in nature. We have spider's web. This is a wasp's nest, sand dunes. So sand dunes have a characteristic shape. They're made of many parts, the sand grains arranged in a particular pattern. And these provide homes for small animals, insects. It also has a role in a desert ecosystem. Okay, and then the other way to classify structures would be manufactured structures. These are man-made, built by people. They're usually, like many manufactured structures, are actually modeled after natural structures. For example, a fishing net, it's very similar to a spider's web. Flippers would be another example. Flippers for swimming are very similar to the fins and the webbed feet of ducks. Okay, and then structures can be classified by the way they're built, so the shape, the materials, how it's put together. The design refers to the shape and size of a structure and the materials of which it is made of. So that would be the design. And there's 3 types we're going to talk about. So mass, frame, and shell. So mass structures we'll talk about first. These are made by piling up or forming similar materials into a particular shape or design. So for example, a sand castle, a brick, mountains, snow sculptures, dams, even foods like cakes and breads. Those would all be considered a mass structure. The advantage of a mass structure is that the structure is held firmly in place by its own weight. So here is an example of a mass structure. This is a dam built by beavers. So it's made by piling up all these pieces of wood. This is another example of a mass structure. This is the arrangement of layered bricks. This pattern here is called a running bond. It's used for strength. Notice how the bricks are laid and how the next brick is laid on top in between the 2 on the bottom. This example here is looking at a mass structure. This is a dam. It's still an example of a mass structure, but it's not always completely solid. This is the power dam. So inside the power dam, there are rooms that may hold electric generators. There's also wires and pipes that are passing through the brick and concrete as well. All right, so that's still considered a mass structure. Here we have sandbag wall structures. These are mass structures that are layered. They are used to prevent flooding. They have 4 key elements to avoid failure. They have to be heavy enough to stay in place, but they can't be too heavy so that the so that the earth becomes uneven below it. They have to be thick enough so it cannot be pushed out of place, and it has to be anchored firmly. And next we'll talk about another classification. These are frame structures. This is a type of structure where we have a skeleton of materials that are supporting the weight of other parts. So buildings, houses are examples, ladders, snowshoes, bicycle, tents, those are all considered frame structures. So a skeleton of strong materials support the weight of the roof and the covering materials. And most of the inside is empty space. Okay, so this is showing a frame structure. We have load-bearing walls. It's holding up a frame structure. And then we have partition walls that are dividing the rooms. And next we have shell structures. And this is a type of structure that gets its strength from a thin, carefully shaped outer layer of material, and it doesn't require an internal frame. So it's strong and it's hollow. So examples include like an igloo, an egg, cardboard box, egg cartons, bottles, and pipes. The shape of a shell, it spreads the forces through the whole structure, but each part of the structure supports only a small part of the load. And then the complete structure can be very strong. Some of these are showing flexible structures. They're still shell structures. They're just more flexible rather than being rigid. So for example, like this balloon. Some problems with shell structures is if there's an imperfection or there's a tiny weakness on the covering, it can cause the whole structure to fail. If the shell is created from hot or moist materials, if there's uneven cooling, it can cause some parts to weaken, or even from forces like pushing or pulling on nearby sections. Flat materials are hard to form into rounded shell shape, and assembly of flexible materials is very precise. Therefore, the seams are strong where the pieces are joined. And then we can have mix and match. So many structures, they actually combine designs. So an example like football helmets, it's a shell structure, but then the opening in the front of the helmet, it is a strong frame. Okay, so the shell structure protects the head, and then the frame structure in front protects the face. Therefore, the player has protection, but it also allows visibility and ventilation. And then hydroelectric dams, we talked about, it's a mass structure, but there are rooms inside for electric generators, and those are built from strong frames. This is a domed building. This combines a shell and a frame structure. Warehouses, there's often columns that support the roof. And then the concrete blocks, they stay in place because of their weight. So the concrete blocks is the mass structure. And then all the columns inside, that would be forming a frame structure. Okay, we'll pause here and watch this video.